Hey there, this is Jacob from Roboflow, here today to talk about Roboflow 100, a new rich multi-domain object detection benchmark. So here at Roboflow, we are all about helping people finding out how to train custom computer vision models on their datasets. And you may have seen some of our other YouTube videos like how to train various architectures like YOLO v5 or YOLO v6 or YOLO v7 or all the different architectures that are out there. And so the state that we have found is that in object detection research, people are primarily optimizing their models on COCO for a fixed metric like MAP on a benchmark like COCO, which contains objects that are in the real world. So things like people and chairs and things like this. Now, these benchmarks are definitely effective at showing, a general direction in which a model is going to perform, but they're not necessarily indicative of how that model is going to perform on your data set. And we see this time and time again, where various different models and different approaches will do better on different single domains. And another theme that we're seeing in the object detection world is that people are starting to train zero-shot models. So these are models that can make an inference without having to do any fine-tuning. So you don't have to show the model a data set. It maybe already kind of understands semantic context within language, and then it's able to draw bounding boxes or classifications right out of an image. And so for people who are doing this kind of research, a benchmark like COCO may not be the best thing to model on because to evaluate on rather, is because it contains images that are all scraped from the web and maybe are already indicative of the data that's being trained. Well, the truth is that people are using models to fine-tune into domains that are very specific. And we see this every day at Roboflow. So we decided to release and design this benchmark to be more indicative of the whole universe of data sets that people are training models on. So in order to form this data set, we drew it first from Roboflow Universe, which is where the public-facing side of Roboflow, where there are over 100 million images, 110,000 data sets, and these data sets and projects are evolving every day as different Roboflow users are annotating their data and working on tasks to apply computer vision in the real world. So we saw here that people are working on more than just things like web imagery or a photo of a dog or something like that. They're working on things like an aerial airport, or how to model playing cards, or some of these like different more niche things. So we assembled Roboflow 100 by combing through this vast repository of data, first sorting by labeling hours. So we tried to find projects that people were working on seriously, and then we started to cluster these things into the domains that people are working on. So people are working on domains from aerial to video gaming to microscopic to underwater, documents, electromagnetic, real world. And these were categories that we kind of started to slot the different things that were being worked on to start to create a more vast distribution of the way that images semantically manifest themselves in real world cases that people are doing in the world for real today. And so that's what Roboflow 100 is. It's 100 data sets that span these 7 different categories. And you can see that we collected quite a few images with quite a few different classes and annotation hours that people have spent on these images. And so now we're releasing this formal benchmark. And you can see that we started to do some initial work on sort of getting the ball rolling on evaluating on this data set. So we evaluated a few different models. We evaluated YOLO v5, YOLO v7, and a zero-shot GLIP. So this isn't necessarily to say anything about the models in particular, but it's supposed to show that there is quite a bit of intravariation between different models and architectures on data sets. So you can see that in some cases, YOLO v5 is doing better than YOLO v7, and in some cases, YOLO v7 is doing better. And in a lot of cases, the other big takeaway from our initial eval is that GLIP and the zero-shot models actually, if you look at them evaluated on COCO, you can see that they're actually approaching pretty quickly these other models that are fully fine-tuned on the COCO data set. But when you go and look at some of these more real-world domains or more obscure domains like underwater or microscopic, these models are actually not performing up to the level that a fine-tuned model is. And that's because some of the concepts that are in these images are a little bit more obscure than the training data set. And so that was a big motivation for us to kind of put this together, is to encourage people to start thinking about these sort of applications and thinking about the way their models might be generalizing. And we think that might be useful for people who are designing object detection models to be fine-tuned, like YOLO v5 or anything in the YOLO family, as well as for people who are working on general models like GLIP or DTIC or things like this. And we've certainly started to see some traction where people are starting to do things like this in the object detection community, like the object detection in the wild data set, which is 13 Roboflow data sets. This was used in the evaluation of GLIP. So definitely people are starting to think about this, but we wanted to do some work to put together a more formal benchmark using our own APIs and some of our more ingrained ways to interrogate the way that people are designing and creating these projects, and then to release this to the community. So that's sort of a broad summary of what Roboflow 100 is. And now I'll tell you a little bit about how you can use it if you're interested in using it for your own research, or perhaps just you want to peruse around and see it. So we are releasing this GitHub repository along with our paper and our datasets, which is a utility for you to use these datasets. So you can see here that we have the aerial and video gaming and microscopic. We have the various categories broke down here. And you can see how many images are going to be in these. And you can also see here when you get started how you can download this benchmark. And then if you sign up for Roboflow, you'll quickly get an API key that you can put in here. And these Docker containers are commands that you can run to download the data. So there's a few different scripts here. There's one that allows you to just fully raw download the data and then start using it however you wish. And then there's also ones where you can replicate our evaluation. And this might be a nice starting point if you're working on, maybe making some tweaks to some of these models or wanting to evaluate across this suite of things. You will be able to do this with similar code that we have in these files here. So that's a pretty broad summary of what Roboflow 100 is. I guess the last thing I want to show is a visualization of how you can see the different semantic manifestations of the Roboflow 100 dataset here at rf100.org. You can see here that each dataset is sort of split out in the semantic space. So here we used the clip model with TSNE clustering, and you can see that different datasets kind of form themselves in different places. And you can definitely see here, how each one of these really is its own, each collection of these images is its own domain, and it is its own thing. So I definitely think some interesting research will get built on top of this. I very much thank you for watching this video today, and stay tuned for more things on our YouTube channel. Exciting things are going on here every day. So we'll see you soon.